So in chapter 3, we're going to talk about two different types of functions, polynomial functions and rational functions. First, we're going to focus on polynomial functions, and in 3.1, we specifically focus on quadratic functions, which is a type of polynomial function. So we're going to start out here, just telling you what a polynomial function is and some of the important pieces that go along with it. Okay. So quadratic functions and models. A quadratic function is a polynomial function. All right. So here's the definition for a polynomial function. So it has it comes in this form right here, where you have these terms, like there's a term, there's a term, there's a term, there's a term, and there's a pattern to these terms. And this is how the function is written, okay? So the n here represents the highest degree of the function. So if you have like x to the 5th and all the other exponents are less than that, then x to the 5th would be the first term. And see, then the next term would be x to the 4th, and then so on and so forth until you get to the constant at the end. So an example like what I'm talking about is f of x equals 5x to the 5th minus 6x to the 4th plus 3x cubed minus 8x squared plus x minus 7. You could have something like that, okay? So that would be a polynomial function. Your exponents are not negative, and they're not fractions. They're integers, okay? By the way, the exponent here is 1. Your coefficients, they're called the coefficients. Those are the numbers in front of the variable term. Also, there's only one variable in these polynomial functions. Okay, so it's in terms of x in this case. Okay, so these coefficients, it says they're complex numbers. For our purposes in this textbook, the coefficients are going to be, so coefficients for these polynomial functions are going to be real numbers. They can be complex, but for what we're going to be doing, we're going to have real numbers. Okay, so when you look at a polynomial function, the degree of the function is the highest exponent. So, like in my example here, it would be 5, right? This 5 right here. So it would be a 5th degree polynomial. It's n. The degree is n, your highest exponent. The leading coefficient, you know what, I'm going to make this a 15. Sorry to change it on you, but I don't want you to get the 5s mixed up. The leading coefficient, that comes from your leading term here, the highest exponent. Notice that the exponents go in descending order, 5, 4, 3, 2, 1, and then the constants at the end. Oh dear. Sorry about that. It accidentally started a new page. Okay. Yeah, your exponents have to go in descending order for it to be in the order of a polynomial function. So the first term is the term with the highest exponent. That is the coefficient then, the leading coefficient is the one on that term. So it's a sub n in our little form here, right? Like they're matching up. A sub n means that's the coefficient for the nth term. A sub n minus 1 means that's the coefficient for the n minus 1 term, and so on and so forth. So our leading coefficient in the example is 15. Okay, so it's the coefficient on the nth term. Okay. The dominating term is that leading term. So sometimes I'll call it the leading term. But in our case, well, it would be a sub n x to the nth. that's the one that's going to have the most power in the polynomial because it has the highest exponent. So when it's affecting things, it's going to have the highest value when you're plugging numbers in and stuff. In our example, the dominating term would be 15x to the 5th. Okay, in the next video, we're going to practice identifying these things.